Welcome to another episode of Science with Surback. Today what we're going to be talking about is section 11.3, which deals with the topic of motion and force. Before we get to the specifics of the notes, I just want to outline a couple of objectives that you should be able to accomplish by the end of this lesson. So the first objective is to determine why scientists identify what scientists identify as the fundamental forces of nature. Objective number 2, determine what happens when there is a net force acting on an object. Objective number 3 is to determine what force always opposes motion. And then the fourth and final objective is to determine why friction is sometimes necessary. So we start out here with a very basic definition of our force. And force is just defined as any action exerted on an object that changes the state of motion of an object. Now, within our forces, we can break them down into 4 fundamental forces. So the first of these forces, which is the strongest, is a strong nuclear force. And an example of a strong nuclear force is the force that holds protons and neutrons together in an atom's nucleus. Now, even though strong nuclear forces are the strongest, they only act over a short distance, so you do not experience them directly in your everyday life. Now, the next strongest force is the electromagnetic force. And an example of electromagnetic force is something such as friction, which is a direct result of this force. Now, the third fundamental force, which is a little bit weaker, is our weak nuclear force. And so an example of a weak nuclear force is something such as a beta decay, which is a nuclear chemistry or a nuclear reaction that occurs from nuclear fission. And then our fourth and final force, which is the weakest, is the force of gravity. And so an example of the force of gravity would be the force acting on the moon and Earth, or really any other object that has mass. Now, remember, with the force of gravity, it's the weakest, but it can be or have a force over some of the greatest distances. So, yes, just a reminder, I did put them in order from strongest to weakest, but another thing that needs to be considered is how great of distance do these forces act. Strong nuclear forces, very, very strong, but they only act over a short distance, very, very small. Force of gravity, very weak, but it acts over a great distance. So you have to consider that when you're thinking about the 4 fundamental forces. Now that we have those forces in mind, these are things that all play a role into the overall effect of our force. So what we can do is we can define some additional terms that help us locate or help us identify specific forces that we need to be aware of. So that first specific force that has a unique term is known as a contact force. And a contact force is essentially push and pull forces. And so some really good examples of contact forces are something such as pushing a shopping cart or catching a ball. And if you look here, again, a contact force, this person is pulling in and out on a spring attached to the particular wall. Again, we actually have physical contact to produce that particular force. The next type of force is a field force. And field forces are forces that do not require objects to touch each other. And so one really good example of a field force is the attraction of gravity or repulsion between like magnetic poles. So again, to have an example here, in this bottom right-hand picture, you can see that the iron, which is magnetic, as it gets closer to one end of the magnet, you're going to start to feel that pull or push that comes from the magnetic fields. And again, that is something where you can feel it without those magnets touching. And then just something to note here, that both contacts and field forces can cause an object to move or stop moving. Again, I just ran out of a little bit of a room here, but both contact and field forces can cause an object to move, and also they can cause them to stop moving. So now we need to focus our attention here to net force. And now net force is just defined as the combination of all forces acting on an object. And so with this in mind, it's really important to note that whenever there is a net force acting on an object, the object accelerates in the direction of the net force. Again, whenever there is a net force acting on an object, the object accelerates in the direction of the net force. To go along with that, an object will not accelerate if the net force acting on it is 0. So to help you visualize this, what I have here is a picture of two things. One, these two people are pushing against with equal forces on this couch. Now, because they're pushing in opposite directions with equal forces, the couch doesn't move or it doesn't accelerate. Now we switch gears here, and these people both use the same amount of force, but they both push in the same direction. There is an acceleration because there's an overall net force occurring on this picture here on the right. So now that we have that in mind, how things can operate, we can shift our gears and we can talk about balanced versus unbalanced forces. So we start here with balanced forces. And balanced forces are defined as forces that act upon an object that produce a net force of 0. Again, the key thing here is net force equals 0. Now, an important point here is because there's a net force of 0, this does not change the motion of an object. And what that ultimately means for us is that it does not cause an object at rest to start moving. All right, so one of the best ways to think about a balanced force is that if you have a light, like a chandelier or something like that in your house, a light hanging from the ceiling, which is at rest, the upward force due to the tension in the cord balances the downward force of gravity, and overall you have a net force of 0, which means that that light or that chandelier is not moving. Again, that tension from the cord where the light is hanging balances that downward force of gravity. Because we have a balanced force, we have a net force of 0, which means that light is not moving. Now, another really common way for us to understand balanced versus unbalanced forces is a game of tug and war. So let's say we have the juniors and seniors, and they are equally matched. And what happens here, if they're tugging on the rope and they're both pulling in opposite directions with that same amount of force, the rope's not going to go anywhere. You're going to have a very even game of tug of war, and that's because you have a balanced game of that tug of war or a balanced force. Now, on the flip side, we have an unbalanced force. And an unbalanced force is just defined as a force that acts upon an object that produces a net force greater than 0. So now an object with an unbalanced force is going to have or is going to accelerate in the direction of the net force. Okay, so the next part, it's a little bit wordy, but it's really important. And that is this. For an unbalanced forces that are applied to objects in different directions, the force acts like a single force on the objects and causes acceleration in a direction that combines the direction of the applied force. Now, I'm not going to write this down, but you can just listen to this example. So, for this last point here, if you push a box due east and your friend is pushing a box to the north, the box will accelerate in a northeasterly direction. Now, a really good way to think about this is a game of tug of war where the freshmen are taking on the seniors and we get a net force. And so in that case, typically the seniors are much, much stronger than the freshmen. What happens here is that because there's an overall force of those seniors pushing or pulling the rope, because there's an overall force headed in their direction, that causes the rope to move and all those people associated with it to move as well. Okay, so the last thing, last major topic here that we're going to talk about is our topic of friction. All right, so moving on to friction. So friction is simply defined as an unbalanced force that opposes motion between two surfaces that are in contact. Now, it's important to note that the force of friction always opposes the motion of an object. And it's also important to know that the force of friction causes an object to produce energy in the form of heat. Now, I meant to add in a section of notes here. I should have placed them right after this portion of friction, so you can go ahead and just add these to your notes. Again, a separate piece of paper or the back of one of these sheets of paper. But this information I'm about ready to tell you should have went right after friction. And so we need to talk about the types of different friction. And the first one is static friction. And static friction is the friction between two surfaces that are stationary or at rest. Kinetic friction, on the other hand, is friction between moving surfaces. Now, we can further classify kinetic friction under two different types. The first of these types is known as sliding friction. And sliding of friction occurs when objects slide past each other. And so a really easy example that you can do here with sliding friction is if you put your hands together and you rub them, you have your hands sliding past one another, and that is a form of sliding friction. The other type of kinetic friction is rolling friction. And rolling friction occurs when rounded objects roll over a flat surface. So let's take, for example, this pencil here. Again, it is rounded, and so when it rolls, it's going to roll over a flat surface, and it's going to have what we know as rolling friction. Now, it's also important to note here that generally sliding friction is going to have a greater force than rolling friction. And it's also important to note that static friction is greater than kinetic friction. And this point here is in terms of the overall force in those particular applications. Now, just one last thing here is that the force between molecules of two surfaces is greater than the force of objects in motion. So that kind of helps tie this last point all together. Now, again, I had to add another piece of paper past this original one. So again, should all be under the idea of friction. I'm just adding to what was originally in notes. So we get here and we get to the function of friction. And so friction is necessary for many everyday tasks to work correctly. So let's take example, the use of friction in a car. And so one use of friction for a car is, one, tires of a car are able to push against the ground and move it forward. Another function is that brakes use friction to allow a car to stop. And then as you're driving, the grip that you use to hold onto the steering wheel allows you to turn the car. Without friction, you'd slide or never be able to grasp that steering wheel. Now, another example is the friction between paper and pencil that allows you to leave a mark on paper. All right, so again, those 2 pages, I didn't insert in there. You can insert those yourself just on another piece of paper or a backside of another piece of paper. What I'm going to do is I'm going to transition back to where we left off, where I made that blunder here, and restart talking about increasing and decreasing friction. So with increasing and decreasing friction, we'll start with this. Increasing friction is caused by making surfaces rougher. So I have 3 examples of increasing friction and their function. The first example is scattering sand or salt on icy roads to keep cars from skidding. Another example is wearing textured batting gloves when playing baseball to make it easier to grip the bat. So now we can move over to decreasing friction, and this is caused by making surfaces smoother or more slippery. And a few examples of decreasing friction and its function is using low friction cooking materials such as nonstick coatings so that your food doesn't stick to those cooking pans. Another example is using that air that comes out of the holes in an air hockey table to act as a lubricant, and it decreases the friction, so it allows that puck to slide from one end of the game to the other. Okay, so the last thing that I want you to be aware of, you don't have to write this down, but it ties everything that we talked about with forces and with friction all together. So I'm going to take this page away here, and I just want you to be aware of this. I put this together, and it talks about increasing and decreasing friction of a car. So without friction, those tires are never able to make contact and push that car forward, so it can't allow it to move. So we need that friction to be able to allow that to move. And then also, as the car moves forward, the force pushing the car forward is greater than that force of friction. That allows you to move, and you have an unbalanced force moving forward. Again, you still have the force of friction, but that engine is powering those tires to be able to overpower that force of friction. And then that last thing is that if we don't apply any more or use any more of that engine, the car will stop to move because of friction. So again, friction, we have to have it to be able to move left or right, back and forward. We have to have a greater force than friction to move forward or backward. And the force of friction is always going to be with us, so we have to keep applying that particular force to just keep moving that same speed. All right, so this concludes another episode of Science with Surbeck. Make sure you add in those particular notes I needed to add in. And at the same time, these 3 problems go with the notes. You need to do these 3 problems with these notes. And as always, make sure you subscribe.